Hi, full room. Was not expecting this. This is cool. Third day of LambdaConf. Let's go. This is Functional Programming, the Enterprise Edition. So I'm Narek. I am a senior software engineer with Salesforce. You can find me on Twitter at @portalgnarlish. I am a Scala programmer and general functional programming advocate. Just a little bit about what I do over at Salesforce. My team is called the Activities Platform. We ingest millions and millions of customer events per day, particularly in the context of improving the lives of salespeople. So we ship a few very useful products, one particularly being the Salesforce Inbox, which does email analysis in real time and is able to help salespeople figure out what's going on in their communications. So we are hiring. We are pretty much on a standard big data stack. We write Scala on Spark. We do Java in Storm. We've experimented with Akka. We rely heavily on Kafka, Cassandra, MongoDB. The buzzword list goes on. We use all of it. So please talk to me if you're interested in doing some JVM stuff with us. So to get started, let's take a roll call. Who is writing Scala at work? Almost the entire room. Okay. Any other languages? Clojure, Java? Okay, other people are in there too. So that covers everybody. All right. Haskell as well? Of course, of course. Is it purely functional? No. So is enterprise functional programming an oxymoron? That's kind of a topic that I've gone through a little bit because we use quite a bit of Scala, and to give some context, Salesforce is a JVM heavy and almost JVM exclusive company. And our division specifically has brought in Scala in the context of Spark and Akka, like I mentioned. So I wanted to know if it's possible to do pure functional programming in the enterprise. And as you're probably aware, Java being an imperative language, folks coming from that world, there's a bit of a brain change that needs to happen, right? Like there's a mindset that needs to shift to start thinking functionally. So let's compare what our preconceived notions are about enterprise code and functional code, right? So when you think of enterprise code, you think of impure, you think of side effects, right? Maybe complicated depending on how large of a system it is. It may need refactoring because 10 to 100 people have touched it over the scope of 10, 20 years maybe, depending on the company. And then when you think of functional code, you think of pureness, elegance, safety, provability, all these great abstractions, type classes. And then you also think of, the people writing them are math geniuses sitting in an ivory tower. But what if I shifted the labeling a little bit? This is realistic code. This is ideal code, right? Only in a closed environment can you really, really have pure functional code. So that's kind of the idea that we want to explore is there a middle ground? So my thesis is, we'll never be perfect, but functional programming is possible in the enterprise. And there are quite a few abstractions in the functional domain that are well suited for commercial software development. But of course, given that the entire world is essentially still in the imperative mindset, we have some resistance that we need to come through. So bringing up functional programming at work shouldn't have to feel like this, right? But sometimes it does. Especially you submit a PR, you're introducing a new library or a new concept, you're using monads or something like that, and folks are, fear, uncertainty, and doubt comes to mind, right? But it's the case because the imperative mindset is the default, right? And why? Blame Fortran. In this nice little illustration from the land of Lisp, the author there's a longer version of this timeline, but the author says that effectively Fortran took over in the programming space, even though it came out in the same time range as Lisp, right? But because businesses were very on board with it, right? And so over the years, then you see the COBOL monster popping up, and if you keep going in the 90s, you have the Java beasts coming out of the ashes of both of these languages, and functional has remained in the backseat. Another reason why we're still in the imperative mindset you can blame universities, and not in a bad way necessarily, but it's the fact that imperative comes first at most universities, right? What is like CS 31 or 101 at your college usually? C, C++, Java, right? Maybe Python depending on the school. And if there are functional concepts, they may come later in like a PLT class. And also there's this kind of myth that like functional programming languages are too high level to teach fundamentals with. Of course, if you're talking about memory allocation and very low level systems things, that's probably true. But it's a good place to start in programming, and we don't, unfortunately. And the other thing is, and we've already touched on this, is fear, right? So the other reason is fear. Programmers are afraid, right? You see category theory, you see type classes, all this scary stuff, and you know, the imposter syndrome kicks in. I'm not a math PhD, I don't get this stuff. Managers are always asking, how are we going to maintain this when you leave? We'll answer that question. And of course, you have the folks that are just against it, right? And so luckily I'm in good company here with LambdaConf, right? I'm preaching to the choir, but you may know some folks that are outright not down with functional programming. So what's to talk about? Let's get to the point. It's in two sections. I want to talk about some functional abstractions that are very, very well suited for enterprise programming. We're going to go through some kind of fun toy-ish examples that have hopefully sufficient depth and relatability that we can walk away with. And then on the other end of this, I want to talk about strategies for fostering and introducing functional thinking where you work and program, especially if you're in a commercial development environment. So some caveats about the talk. I'm assuming familiar with Scala. I think we're covered on that. And I'm going to use some kind of Java-esque Scala to do the imperative duels to the ways I want to solve these problems. It is not a first principles talk. I'm going to focus on applications here. Any category theory stuff or type class stuff, I will probably hand wave over and touch on at the end. If you want to get into the theory, FP and Scala, the Bjarnason and Chusano book is incredible and probably the foundation for most of my knowledge in this space. And then we're going to use the CATS type class library as well, though you could easily drop in Scala Z into this to do the same examples. So let's get into it. Applied functional programming abstractions to use in the enterprise. Who's seen this comic? Right. Code written in Haskell is guaranteed to have no side effects, right? So what's the deal with effects? Effects versus side effects, I think there's a distinction, right? So any type of effectful computation is something that changes the world, right? You're mutating a database, or you're reading from a file, or you're writing something back to disk. The difference between the two, and as John DeGoes touched on this morning, is one is accounted for and one isn't, right? In pure functional programming, we have values that represent these things, right? I think he described them as boxes. Whereas a side effect is just something that happens in the midst of your code running that has no, there's nothing tied to it. There's no like artifact of it happening, right? That's like void. Like you write a function void, I could do a million things, right? There's always the fire the missiles example, right? In a function that's supposed to just add two numbers, you have a call to fire the missiles, and all of a sudden, you're doing side effects. So some common computational effects that we're going to cover here: partiality, failure handling, and I/O. The examples are kind of going to go up linearly in terms of kind of depth or complexity, so we'll just jump directly into it. And so one other thing I wanted to touch on before we get to it is the fact that computational effects are central to enterprise programming, right? You need to talk to the internet. You can't have an application without using network operations or databases or file stores, right? And of course, composition is the essence of functional programming, and we need to be able to compose effects. That's the point. But how do we do it, right? So this is the only category diagram that we're going to see here. If I have some A's and getting to B's requires some effectful context, and I have a B and I want to get to C via some other effectful context, I need a way to get from A to C, right? Like I need that composition to happen. So that's kind of what we're going to explore here. So partiality, we're probably all pretty well familiar with this. It's just a mathematical concept of not everything in the domain mapping to a codomain, right? This is the case usually handled by null in Java and other similar languages. And it happens a lot in the enterprise because you have empty database selects, right? Like you ask for something and you get nothing back. You have to represent that with some kind of empty value, right? And of course, yeah, null is the most common way to deal with this. But the problem that comes with null is null pointer exception, right? And it doesn't play, it doesn't work. So of course, Scala has option, right? We've all seen this one. So they introduced this to mirror the maybe type that's in Haskell, as well as to solve the Java null problem. It's very simple, it's very powerful. It effectively is an algebraic data type where you have either a none, which represents no value, and then you have a sum wrapping an A. Sum is a type constructor that effectively will say there is a value. So great, we have a type constructor, right? It represents partiality, but what are the imperative people doing with option? They are using it just like Java null. And that defeats the entire purpose of the abstraction. So I want to use kind of a simple example to get going here. We have two maps in memory here. We have a person to location mapping, and then we have a location to transit lines mapping here. So what we want to do is we want to look up in one cache, and then use the result from that cache to look up in the second one, and then do some operation on the list and return a value to the end user. And of course, Scala's map has the get method that returns an option of v, which is the value for any k key that you pass in. So what we want is something called list stops that, like I said, selects a person, selects their subway stops, and then transforms those stops into like a comma-separated string just to have some added functionality. Here's the imperative way, right? Like it's a mess. You have to first do a lookup on the person, then check if it's defined, and if it's defined, do a lookup on the transit stops that they have. And if the transit stops are defined, then we're going to create a mutable string builder, loop over all the elements in the list of transits, and then output the message finally at the end, or have some error message. So, I mean, the Scala way is like, I could fit two examples on one slide, and we could probably even get shorter than this, but the idea is that we're doing person location get by name, right, in the first example, and then we're flat mapping to location transit get, right? So all I'm doing is, just like we saw in that diagram, I'm taking my A, getting an effectful B, taking that B and getting an effectful C, right? It's just composition, and this is the crux really of what I'm going to talk about today, is this idea of being able to take this context and bind it together with another one. And then after that, we're going to just do a little reduce on the list that comes back, and then have a get or else like return value. A little bit more interesting, if you want to reduce one line in this, you can use fold, or at least one method call, right? So the nice thing about fold in Scala is that you can have a default value as your kind of z, as your left side, and then it's curried. You have the other side, a operation on your success value or your present value. So why does the imperative style make things so complicated? Like this is a simple thing, and we're able to solve this quickly because it lacks effect abstraction. Like we don't have that. We have to reinvent the same computational patterns over and over and over again. And of course, with functional programming, we don't have to do that, and we can make this nice little declarative pipeline like I just showed. Yeah, and of course the difference is we're using combinators as they were intended, right? We're not checking is defined. We don't care. We're just going to go on to the next thing and just chain all these operations, and if it fails, it'll short circuit. Like that's the essence of this. So we're trying to combine effects. We need to use combinators, namely flat map and map. So a quick aside about folds, I just mentioned that there's the fold method on option. They're everywhere in functional programming. I believe Tony Morris is giving a talk on them today at some point. The foldable is a type class in cats and Scala Z, and we have fold in the standard library as well on essentially most of the collections. But the thing that's maybe not obvious is that non-collection types are foldable too, namely algebraic data types are foldable, just like we showed in option. Either has the same thing, try has the same thing, and we'll see that in action. It's just a nice little flair that we can add onto these types that we're using to do quick default or act type of actions. Oh no, something failed. Failure, that's the next context we want to talk about. Exceptions are natural in programming, right? They're in every language, they exist. Enterprise people know them too well. I can say that we've had quite a few issues with null pointer exceptions and other things in production, and it's always a nightmare. And of course, traditionally, you deal with this using try, catch, finally, right? Everybody's familiar with this pattern. But the problem with try, catch, finally is that there's, again, boilerplate, and we're reinventing the wheel every time we code. So Scala handles exceptions a couple ways using either and try, right? Try is in the util library, either is in the standard library. They are also both algebraic data types, as I'm sure most of you are aware. Either is a little bit more generic. I've shown this here with throwable bound to the left side. You can also just have A and B if you have some error string that you want to collect in the left. And I believe since Scala 2.12, either is right biased. So you can actually get away with not having to ask for left and right when you do things with an either object. And of course we have try as well, which is a similar thing, but in the algebraic encoding, you have failure as its own thing, whereas either is a little bit more generic and you can put something else there. So failure is always going to have a throwable, and your success side is going to have your value, which is the A that's shown here. So the example that we want to show here for failure is modeling a website sign-up flow, right? So I have this sign-up flow method here that's going to take an account request and return an account response, okay? So we have account request. It just takes a username, a password, and an email, and then an account response is either denied or granted. And the denied one will just capture some error message. The granted one will have an encrypted password and a validated field for whether or not the email is good. So the problem that we have here is that the encrypt function has an unchecked exception. If the input of the password contains the word mailman, it's just going to throw an illegal argument exception, and then otherwise it's going to do a left shift on the representation of the string to do like a simple cipher. And of course our validate email one looks okay, doesn't actually throw an exception, but can anybody spot the bug in this? It's in the last line. Yeah, head. Calling head is very, very dangerous, yeah. So there of course is head option, but let's just say the developer in this case didn't know that head option existed. So you can get this no such element error when you call head. So the Java style for this actually looks quite simple, especially in comparison to the cache thing that we did before, right? You're just opening a try block, you're trying both things, creating a granted object, returning it, and then if you catch an error, you're going to return this denied thing. And I'm giving them a break here, right? Because a lot of people would probably just return null in this situation. I'm actually returning a type. So we're giving them a little bit of slack. So try-catch makes this simple, but what if we wanted to chain multiple of these things together? And of course, you can't do that because the imperative version of this doesn't compose, especially as this gets more and more complicated. All right, so here's the way that we would do it in the functional style. We have, I think, 3 different implementations of this. The first one is kind of the most kind of basic combinator way of doing it. You're trying the encrypt, right? Flat mapping, grabbing the encrypted message if it exists, trying to validate the email, and then mapping over on the inside of that the valid email into a granted object, and then folding it, right? And so we're packing our throwable into the message and denied. Otherwise, we're just using identity to return the granted object. This is a little bit tedious, right? Like it's a little bit too nested. It's not that nice to read. So of course, we have for comprehension to solve that problem. In the Haskell world, I think this is do. I'm not sure that they're entirely semantically the same, but it's very close. So what this does is it kind of sugars away all the nesting and all the stuff that we don't want to do. We can just say, try this, put it in the encryption object, or sorry, the encrypted field, put it in the try the validation, put it in the valid email, and then yield a granted thing. And we're just doing the fold at the end to finish the pipeline. Another way too, actually, is if you notice, these are not necessarily related because we're not actually piping the values together. We just needed to nest it to make that object. There's a thing in CATS and Scala Z called applicative that lets us do these both in parallel and then join them together using the map2 method on there. So this is a kind of cool little extra credit one. So far we've only dealt with objects in our program, but there's a whole world of data out there. And we said enterprise apps are not useful without I/O, so we need to talk about I/O. So communicating with external resources is critical. We need to do it. The imperative world does not have a principled way to do this. You could probably just shuffle all this stuff into try-catch blocks and catch your I/O errors and do all this type of thing, but it's like, it's not right. Like, you have a more specific case. You're talking about an actual a call to something outside. You also have like async await, and you have like Scala's future as well, but none of these are referentially transparent. Like you are not going to get a value back. Future, I believe, just takes callbacks and returns unit, so it doesn't work. It's not pure. So I'm going to introduce CATS I/O. Are people familiar with CATS and Scala Z, by the way? Like majority? Some? Okay. So the idea is that CATS I/O will give you a value. So all of a sudden a function that you have that makes a network call or a database call is now referentially transparent, and we have something to return. It's no longer just unit. It's composable, and as we'll see in the examples, it allows the separation of execution and action. So you can compose programs and make values and then figure out how to run them later. And of course, with the control, you have many different ways. I've only listed a few methods here, namely unsafe run sync. That's the one that most people seem to be comfortable with. Unsafe is not a bad thing. It's just it's intended to be used kind of at the end of your program and not in the middle. Run async, I believe, will run similar to future. You have an attempt, which is a better way to do unsafe run sync. It'll return you an either if something goes wrong. And then you have cancellation as well that's built in. So the I/O example, this is probably the most complicated. We have this time 3 different caches, but they're meant to represent a data lake, right? So this is a schema-less data lake that has kind of some soft keys between them. Up top, we have the restaurants data lake that has search terms, and it points to a restaurant object which contains a location. So we can, as the enterprise company, we can serve up restaurants and their coordinates based on a search term that a person wants to give us, right? And then we also supply a reviews data lake where, based on a restaurant, we have a list of reviews that somebody's written for that restaurant, right? So we want to do first a search restaurants method that returns a tuple of restaurant and coordinates, right? So we want to, again, look up in this first cache, then use the location of the restaurant, if it exists, to look it up in the second cache for locations, and then pair the two. So we have the restaurant and the coordinates that some application could use to route the user to the restaurant, right? So I've implemented 2 impure methods here, fetch and write. The fetch has a sleep time on it, and then it just gets from a bucket. And we are going to use the map API, so it's option that comes back. And then notice in write that the type signature is, in fetch that the type signature has option, and in write the type signature does not have an option because write is kind of like a unit operation. So what we're going to do is arbitrarily return 1 when this thing succeeds. So we have kind of a representation of the number of rows that were written to the data store. So here's the imperative version. Like, I think we're getting used to this by now, so we'll get through this pretty quickly. You're instantiating restaurant and coordinates as options. You're trying to do a fetch. If it exists, you're fetching coordinates. And then, if some error happens because we're doing this hard get down here, we'll have to log out some exception. So this actually can return null. And then we finally will return a tuple of restaurant and coordinates. So here, for the functional example, I've wrapped IO fetch and IO write. So notice that since the lookup type signature returns an option, we've had to use this thing called option T. Because we're dealing now with IO of option. Now you have two layers of context that you have to like cut through to be able to deal with this. This is essentially just a way to simplify dealing with both layers. And then IO write, of course, will return an IO of int, which is essentially just writing to that bucket and getting that number of records returned. So here's the first way of doing it in the functional style. We're going to, again, take a search term in, and we're going to return either a throwable or an optional of the restaurant in the coordinates. So you'll see up here I've declared a value IO of type option T, which essentially is sugar for IO of option. And it's going to return restaurant coordinates as a tuple. So again, this is very, very short. Using the for comprehension, we're just doing IO fetch on the data lake, then using whatever result comes back to do IO fetch on coordinates, and then tupling the two. And as I mentioned before, we can separate the query and the actual running of the query, right? And I know that there's some like database libraries that allow you to do this as well in the imperative world, but this isn't limited to just a single database driver. You could do this with S3 and a database and the disk at the same time and compose them all using IO because it's a single abstraction that handles these types of effects. The second way of doing it, actually, sorry, this is the second example. We want to search a restaurant and then review it based on the distance, right? So it's a little bit of an arbitrary thing. So you've noticed I've taken the exact same IO object that was in the previous example, so this guy, and put it here as its own function, and this is just a pure value. It just returns an option T of IO of this pair that we want to return. And then I also have another one that's an insert statement, right? So again, this is not an affecting transaction, this is just a value. So in this one, I'm doing IO fetch on the from the reviews data lake based on a certain restaurant, and then picking up the reviews that are already there, doing a fold on the option. So if there's no review existing for that restaurant, we're going to instantiate a list, put a review in it. And then if there is a list existing, we're going to prepend the review that the user wants to put in there. And then ultimately, we're going to use IO write at the bottom to do number inserted and yield number inserted. So here's our lazy reviewer function. This is quite arbitrary, but he wants to look up a specific restaurant, and then based on the coordinates, if the latitude is greater than 40, he wants to just say it's too far and just write a bad review, right? And notice here, actually, this is worth pointing out as well. We have 0.pureIO. So if you notice, my original function in write didn't have like a zero case. I'm adding the zero case here, right? And all pure does is it lifts it into this IO context that we've been talking about. So in the event that nothing gets written, it's just a zero. And then so here, tying it all together, we create one more value that utilizes our select restaurant method that we built before, right, to pull out restaurant and coordinates together. And then we're taking this lazy reviewer guy, putting in the restaurant and the coordinates, and then based on whatever happens, he's going to do some action. Here I'm using option T lift F. That's also a nice little convenience method. Because lazy reviewer returns IO, and we're talking about option T, aka IO of option, it'll just put all of that together into the IO of option context for us. And again, running IO value attempt, unsafe run sync to actually get our result back, which is an either of throwable and optional int. So if you're noticing a pattern, it's because all of these values that we've talked about are part of these type classes, right? And by the third day of LambdaConf, you've seen all of these. So functor, which is effectively the map definition, applicative that we used in that one example where we're pairing the two tries, brings in app, and pure, which is the lift into a context. And then, of course, we have monad, which implements the binding of the context, or flat map, as we call it in Scala land. Also notice that there is an inheritance pattern here. And things can get much more advanced. You've seen already an example of monad transformers and quite a few other nice little nifty features that CATS provides. But given all this stuff, right, like we've talked about this, and we've seen that there's some very, very rich things that you can do with pure functional programming in the enterprise context. How do we now explain it to people, right? How do we teach this stuff and how do we introduce it? As a functional programmer, you have to be a teacher and a salesperson at the same time. This is particularly true when you are in a context where folks are not familiar with what you're doing, right? So this is kind of the essence of the next section of the talk, where I want to do 5 methods for functional programming advocacy that you all can implement when you get back to your day jobs. Number 5, use principled libraries. We have some very, very smart folks writing incredible libraries and tools for us. Some of them are at this conference. It's amazing. Let's use these tools, right? So if you can introduce some of this stuff at work, you can lead by example. People will be curious how you're doing all this interesting stuff and your code is this short. So it's a great thing to bring in these types of tools. In the Scala world, you have, of course, CATS and Scala Z, as we've mentioned. Doobie is a great relational database library that is built on top of CATS. FS2 for streams and Shapeless for generic programming. Number 4, organize and speak. This is my first conference talk ever. So submit practical talks to conferences and maybe you can speak. If not, set up an internal meetup or a book club. Go through the Red Book with your coworkers. There's so many things that you could possibly do at work. And write blog posts. Maybe you're not you don't want to talk in front of people. You just want to communicate via the beautiful languages that we have. So all of this stuff works. Communication and examples are the easiest way to get people up to speed with these concepts. Number 3, this is the harder one. Refactoring things. If you're an enterprise programmer like myself, you're in an environment where you're dealing with legacy code and monolithic code bases, right? You can't boil the ocean if you're trying to introduce functional programming. You're not going to be able to rewrite your entire company's code base in one day, right? So the best strategy for this is to start breaking things up into subsystems. If you have an opportunity to build a microservice, that's your perfect time. That's the exact time that you need to bring this stuff out, whip out the CATS toolkit, and start building stuff. Separating concerns when you're doing that or you're building a library or microservice is the perfect time to start doing principled code. And then the other thing is, if you're writing libraries and modules, if your deliverable is a library that is not a system, that's also a perfect time. You can have the entire innards of a API be monadic and pure and really clean, and you'll get away with it a little bit easier than if you were to do this in some production server. Pull requests. That's another big one. If you are an expert, and I know there are some of you in the room, pull requests are probably the best way to mentor folks and teach them things, right? That is your way to catch bad practices or impure code going into staging and then production, right? And it's a great opportunity to teach. You don't have to just say LGTM and move on. You can look at the code and help folks. That's a huge one, and it's worked a lot for us. And then number 1, you have to check your ego at the door. FP, as much as we all love it, it has a bad rap for being inaccessible, right? People see it, people get scared, they run away. Don't make it worse, right? And that's kind of the idea that I wanted to get across by structuring this talk in a backwards way. Examples first, type classes last, and it seemed to work for me so far. And then, of course, focus on approachability and application, save the theory for later. There's a lot of really good resources, and folks will want to go seek them out if they understand what this stuff is supposed to do, right? If people understand why, they'll want to know how, and they'll go learn themselves. And with that, thank you.